Okay, so hello and welcome back. So in this chapter we want to talk a little bit about the statistics again. So the system in these books is that there is usually one chapter about the statistics in every book, meaning that, for example, in class 6 you have one chapter about statistics, although over there they don't call it statistics. They call it something else, for example, data, I don't know, management or something. In class 7 there is another chapter about the statistics, and I think over there it's already called the statistics. Class 8, class 9, class 10, class 11, and that here, basically over here we have the statistics. Moreover, there is another book over here that you might be interested in. If you go to NCERT.nic.in, and if you go to class 11, and there is a subject here called, besides mathematics, there is another subject called the statistics. So that students in class 11 seem to have another basically completely different subject called statistics, and it's called the Statistics for Economics, and the book is something like this. And of course you can complete the whole book, and it will be downloaded to your computer. It's not that big a file, or around 13 MB, and then of course you can take a look at the chapters. Or if you go to the prelims, I don't know what the word means. Prelim means let me see. Prelim means preliminary. So preliminary. Now statistics for economics, textbook for class 11, and then you have all of these things over here, the foreword, and you have the contents is 134 pages long. You have chapter 1 through chapter 9, so that collection of data, organization of data, presentation of data, measure of central tendency, measure of dispersion, correlation, index numbers, use of statistical tools, and there is a glossary of statistical terms and table of two-digit random numbers. And that's the Constitution of India. Okay, so basically it seems that this book basically kind of talks about everything that has been talked about, starting from class 6 all the way up to class all the way up to here, I suppose. So if you go to this folder, and I have downloaded the book to here, extract all, and you have all of these parts over here. So let's see what we have here. So this is the PS, basically this is the prelim that we had over there, and then here you have the chapter 1, which is all about I think it's about we cannot get something for nothing. And what statistic does. This is some introduction to statistics. This is some introduction to statistics. This is for collection of data. So for example, you know how to collect data using some information, for example, about collection of data, and let me see, random sampling. Well, it's a little bit more advanced than those. I mean, it starts from a point which is a little bit more advanced than those books, for example, class 6. I suppose you need to first read the class 6 book and then come over here. And then you have the raw data. You have the or you might even understand this book without, it's actually the same thing. You might actually understand this book without going through those chapters in starting from class 6. So that's basically the book Statistics that you get in class 11. That means that the book is already there and you can use it. And so I'm going to just simply call it Statistics class 11 and put it somewhere on desktop for now. That's desktop and paste it. Okay. And then you have basically, and then for class 11, you have all of these other subjects, for example, fine art and translation, graphic design, Urdu, economics. There is also economics, which might be interesting, related to mathematics and Indian economic development. I don't know if that's at all related to mathematics. Indian economic development. Let's see what that is. Let's see. Okay, so Indian economic development. So you have a couple of things here, like Indian economy on the eve of independence, the agricultural sector, Indian economy, and you have liberalization, privatization, globalization. Well, it gives you some good information on probably on globalization and privatization and liberalization on a global level as well, probably, but it has nothing to do with mathematics. And moreover, class 11, I want to cover everything which is related to mathematics in class 11. So basically economics, history, political science, English, sociology, Hindi, physics, geography, psychology, biology. There is a statistics, which we talked about, chemistry, accountancy. There is accountancy here as well. So you can of course, go through that as financial accounting, accountancy 2, and there is financial accounting. This would also be interesting if you want to learn accountancy, meaning bookkeeping and that sort of thing. If you need it for whatever purpose, this is also a good book. I always wanted to read this book, but I never actually got the chance, and I never actually needed to do that. But nonetheless, it's a good book for recording of transactions and theory base of accounting and bank reconciliation statement, trial balance and rectification of errors and depreciation provisions and reserves, bill of exchange, and so on and so forth. And there is also accountancy. There is 2 parts to this book. So accountancy, there is also part 2, which is, it's basically 2 books. So this is financial accounting part 2, textbook for class 11, and then you will have probably the same books, only 5 chapters here. So you have introduction to accounting, recording of transaction, bank reconciliation, probably the same thing, but probably more advanced, of course. And what is this? Chapter 9, 10, 11. Oh, okay, so it starts from chapter 9, meaning that over there we had all the way up to chapter 8. Here we have chapter 9 through chapter 13, I'm sorry. Concept of computerized accounting system, and so on and so forth. So if you want to, basically, this would essentially be a kind of a university accountancy course that you would take. For example, they call it business management. In business management courses, they, of course, they do other subjects as well, but the core of business management is usually accountancy, which is what you would learn over here. So these books are, of course, very useful if you happen to need them. But now the topic of our discussion here, and if you go to class 11, then there is Sanskrit and mathematics, and that's basically everything that could be or would be related to mathematics. Now, what we have here is, the topic of our discussion here is statistics of class 11, and that we will cover in this basically in this series of videos. Might be probably about 15 videos or so, probably a few more, let's see. So in the next video, or I will do the introduction here, and then we will move to the main concepts in the next video. Okay, so as an introduction, we know that the statistics deals with data collected for specific purposes. So we already know that. We can make decisions about the data by analyzing and interpreting it. In earlier classes, we have studied methods of representing data graphically and in tabular form. This representation reveals certain salient features or characteristics of the data. We have also studied the methods of finding a representative value for the given data. this value is called the measure of central tendency. So basically we found the median and the mean, and one more thing that basically that showed the measures of central tendency of our data. And recall, mean, the arithmetic mean, the median, and the mode are three measures of central tendency. The measure of central tendency gives us a rough idea where data points are centered, but in order to make better interpretations from the data, we should also have an idea how the data are scattered or how much they are bunched around a measure of central tendency. So for example, basically the measure of central tendency in data is basically, there were three measures of central tendency about the data that we talked about. That was the arithmetic mean or the mean, there was the median, and there was the mode of the data. Now, the mean of the data was, for example, if you have, 49, for example, 57, and 75, the mean of this data is going to be, for example, 49 plus 57 plus 75 divided by 3. That's the average of the data, meaning that basically if you locate these points on a number line, this number, whatever that is, let's say that the number is, for example, of course we don't need a calculator for this, so you have 49, you have 57, and you have 75, for example, and then that's 16 plus 5 is equal to 21, 2, and then you have 6 plus 5 is equal to 11, 18, 181, and 181 divided by 3 is something about 60. It's about 60. So what that means is that if you have your numbers on a number line, 0 here, for example, this is 50, this is, for example, 100, and this is, if this is 14, let's say that this is 49, then you have 57 would be somewhere around here, for example, 57, and 75 would be, this would be 75, I suppose. This would be 75. So the mean of this data is going to be right over here, which is very close to 60. Meaning basically the average of the data. So that's basically for example, that was the mean of the data. Then we had the median of the data. The median of the data, I don't remember exactly. Now there is the median and there is the mode. As we go through the text, we will recall what they were, and these basically what they show you is that what they mainly show you is that basically what your data tends towards when you get to the center of your data, meaning that these are, well, the name also, as the name suggests, is called the measure of central tendency. The measure of central tendency, meaning that it tends to, that your data tends to some central point or central value, and then based on that central value you can make decisions, meaning that, for example, you can say that your data is, the central point of your data is, for example, this value, then based on that I can make this conclusion and that conclusion and so on and so forth. So this is the measure of central tendency. And And of course, then based on basically also as basically additional to the measure of central tendency, you need to know basically how your data is scattered, is basically scattered around these measures of central tendency, meaning that, for example, suppose that you have some data points here. Suppose that you have some data points here, and and these data points are, for example, the mean of your data is this value. So and suppose that basically there are some other data points that are scattered here, over here, all around your data, all around the mean of your data. So of course the nature of this data is different from this data. For example, the same measure of the same mean, for example, this is your mean, but then all of your data points are right very close to your mean or to your average. So for example, then if this data was suppose that, for example, you read some lab apparatus or lab, for example, measurement device. Suppose that you read a laboratory, for example, scale, or a laboratory scale for basically measuring the mass of some object. So if the lab scale is giving you all of these scattered data points all around your mean, what that means is that your scale doesn't have any accuracy. The accuracy of your scale is very low. On the other hand, when the reported values by your scale is, for example, let's say that you have made, for example, 20-30 readings, and this is the mean of all of the readings that you have made. Now, when all of your readings are very close to the mean, that means that the accuracy of your scale is basically much higher than the scale in this case over here. So that's basically one way that you can make sense of these, that you can make sense of, for example, how the data is scattered around the mean. Otherwise, you can make sense of it in any context in many different ways. Okay. So I suppose that's one thing that we want to do here, and we want to know. It says that the measure of central tendency gives us a rough idea of where data points are centered, but in order to make better interpretation from the data, we should also have an idea how the data are scattered, or how much they are bunched around a measure of central tendency. Now, as an example, for example, consider you have two batsmen. So the batsman, you have batsman A, and this batsman A, basically the points that he has scored are 30, 91, 0, 64, 42, 80, 30, 517, and 71. And batsman B is basically 53, 46, for example, 48, 50, 53, 58, 60, 57, and 52. So the mean and the median of the data are related to these two batsmen. So the mean and the median of this data are basically related to batsman batsman A and batsman B. So the mean is basically 53, and over here the mean seems to be the same number, meaning that if you added all of these numbers together and divide by the number of those numbers, you'll get 53, 53. The median is also 53 and 53. I think the median is the number that has happened. I don't remember what the median was. Let me look this up. What's the median? Of data. Okay. Okay, so here basically we have the median of a set of data, and I suppose let's see what we have on mathgoodies.com. So it says that the Doran family has 5 children, 9, 12, 7, 16, and 13. What's the age of the middle child? So, according the children's age from the least to greatest, we get 7, 9, 12, 13, and 16. Then the age of the middle child is the middlemost number in the data set, which is 12. And that's basically the median of your data. So now I do remember, now I can remember what median was. So when you want to find the median of a set of data, for example, in this case, the age of these children, so what you need to do is that arrange your data set in an ascending order, or you can do it probably in a descending order as well, I suppose. And then the data that comes exactly in between, meaning the middle term or the middle number here, is the median of your data. For example, in this case is 12, and and this is actually a very good example to show basically to show the one of the practical applications of median, for example. So that is basically the median of your data. Now, in different situations, of course, the median represents different things, but for example, in this case, the batsman has scored, for example, 64, 42, and these are basically, there is no way to know, for example, I mean, there is no rule for these data points here. So the median, for example, in this case is not a very, I mean, it's not representative of almost nothing, for example, in this particular case. But the mean is representative of basically, based on the mean, for example, you can kind of compare, for example, batsman A to batsman B. Basically, you can say that, for example, on average, for example, this batsman has scored higher than this batsman, and so on and so forth. But otherwise, the median is almost meaningless in this particular case, unless you could find some meaning in this context. If you were more, for example, if you were more familiar with the context, more familiar, for example, with this game, whatever that is. So, and then we calculated the mean of the data, and we denoted by X bar. That denotes the mean of the data. And basically you find that by dividing the sum of the observations by the number of the observations, meaning that we wrote this as x bar, we wrote it as the sum of the observations, by the number of observations. Meaning that in a more mathematical language, you can write this as x bar is equal to sigma or 1 divided by n sigma f of sigma x of I, for example. 1 divided by n times sigma x of I basically I is equal to 1 to n. So that's, for example, that means that all of the x of i's, which are all of these data points that you have here, starting from 1 all the way up to n, you just add them together, and this sigma denotes addition, meaning that this means that if you write sigma x of I when I is equal to 1 to n, that means that you write x of 1 plus x of 2 plus x of 3 plus all the way up to x of n. And then all of these, when you add them together, then you have to divide it by n here, meaning that if you write this, divide by n here, and that gives you the average of all of these of the observations. So, and the median is obtained by first arranging the data in ascending or descending order, and then applying there is a rule regarding depending on whether basically your data, the number of observations is odd or even. So of course I'm just talking casually about all of these here, because we have actually talked about this extensively in earlier classes. If you feel the need, you can go back to this website. For example, right now we are doing class 11, and I don't think that I can go back to earlier classes, at least in this series of videos related to mathematics, because I have done them once and I don't want to do them again unless I really have to, which I hope I don't. So for example, you can go to class 10 and choose the subject, for example mathematics, and then for example here choose mathematics, and if you hit go, you will get to the mathematics class related to the mathematics book related to class 10. And then as you can see here, you have basically one chapter here, most probably one chapter. So this is, for example, arithmetic progression, trigonometry, and you have construction, the statistics. You see chapter 14, and then you can come over here. If you open chapter 14, you have everything. You have 35 pages of material related to, for example, statistics here. And this is, for example, where there is group data, ungrouped data, there's all kinds of things there. You can learn all of these over here. So, for example, this is X bar, and I don't know, class intervals, number of students, and all kinds of things. Simple material, although I have done this, I don't know, some time ago, not a long time ago, and I have actually forgotten most of them. But the concepts stay with you. Maybe you will forget the formulas after a while, but the concepts will stay with you. So So then, for example, this is class 10, that's only 35 pages. And then you can go to, for example, class 9, and then, for example, mathematics, and then mathematics here, and then some chapter over here must be still again related to statistics. You see over here again, chapter 14 is related to statistics, class 9, for example. So again, you have around 33 pages here, all related to statistics. These are simpler than the one that I just showed you. These are related to graphs and histograms and things like that. So that way you can basically go back and learn the things that you might need to know. This way you can learn them. And well, in my experience, that's the only way to learn basic mathematics. I mean, there is all kinds of books, really fancy books, from the Cambridge University, from many different, basically very famous universities, from many different, very basically famous, publications and authors and so on and so forth. And I have gone through almost all of them because I was devising a course on mathematics. But then in my experience, this is the best way to learn basic mathematics free of cost. You just sit by yourself and just go through the material, do the exercises, and that's basically all that you need to do, and you will learn basic mathematics very well. And one more thing that you need to know about these books is that, of course, the level of these books compared to other educational systems is I would say a little. I mean, around, for example, what you read in class 11 and class 12 is something that is the kind of thing that you would probably study in the first year or the second year of a college course, in a university course or something like that, in a mathematics course, for example. So the level of mathematics here is much higher than compared to almost any other possible educational system. And of course you can see that in the books as well, meaning that, for example, if you compare the book, for example, the mathematics book that you can find on, for example, class 6 or class 7, if you go through that book, you'll see that the book has something about 300 pages. 300 pages only for class 6 or class 7. Now, if you go to any other education system and take a look at their mathematics textbook, you'll see that the textbook in most cases, the textbook doesn't have more than 150 pages, tops 200 pages. So there is a lot of material here that has been covered. And if you're basically serious about mathematics, I think you should read these books. The best books I've ever seen in my whole life, really. Okay, so now again, when you want to basically find your median, we said that you have to sort your data in an ascending order or in a descending order. So once you do that, then there is some sort of a formula. It's not much of a formula, but there is something that you need to do in order to get to that middle term. meaning that to that middle number. For example, in the case of the ages that we had, for example, 12, 13, for example, 15, 17, and 21. These are the ages of 5 children. So if I wrote these numbers in for example ascending order, which I've already done, then as you can see, the number of these observations is 1, 2, 3, 4, and 5. So that means that the number it's an odd number. We have an odd number of observations. So since you have an odd number of observations, then of course it makes sense that, for example, since you have, for example, 5 data points over here, you have 5 data points over here, so you take basically 2 of them, you leave them on the left, 2 of them you leave them on the right, and then this is in the middle, that's basically the median of your data. Meaning that the number of this observation, you can find it by basically n plus 1 divided by 2, and this term and this observation is the median of your data once you arrange your data in an ascending or descending order. So this is, for example, in this case, 5 plus 1 is equal to 6, 6 divided by 2 is equal to 3, and that's the third observation. So this third observation is going to be your median. Now suppose that the ages of children were, for example, 12, 15, 17, 18, 19, 23. You have 6 observations. So now the number of observations is basically even. So when the number of observations is even, then you get 2 medians, because, for example, if the number of observations in this case was, for example, 6, then you would have to, there is no middle here. I mean, the middle would be these 2. So you can if you do the same thing that you did before, for example, you can take these 3 together on the left, these 3 here on the right, and then you would have no numbers here. And on the other hand, the only other thing that you can do is that instead of taking 3 on the left, you can take 2 on the left and 2 on the right, and then you would be left with basically 2 observations. So when the number of observations is even, you will get basically 2 medians. And in order to find those medians, you need to find n divided by 2th observation, and also n divided by 2 plus 1th observation. So these 2 observations. Now this is, for example, the number n over here is 6. 6 divided by 2 is equal to, that's the 3rd observation, which is this one, and then 3 plus 1 is equal to 4. This is the 4th observation, and that's basically the 2 medians that you get. So that is that. And then here it says that we find that the mean and median of the runs scored by both the batsmen A and B are the same. The mean and the median are the same. That is 53. Can we say that the performance of the 2 players is the same? Clearly no, because the variability in the scores of batsman A is from 0 to 117, whereas the range of the runs scored by the batsman B is 46 to 60. So again, in the case of the data that we had here, you see that the data goes from, for example, even 9117, 0 to 117, and this data ranges from, I don't know, ranges from somewhere about 52, 48, 46, 46 to basically 46 to 60. So, of course, on average, both of them have done equally the same. But for example, this batsman A has had a score of 117. So now it depends on you how you want to interpret the data, of course, based on different situations, but that's basically, for example, how your data is scattered all over the place. So, because the variability in the scores of batsman A is from 0 to 117, as you can see here, and so that you could call the minimum of your data, and that you can call the maximum of your data, the maximum. And again, here you have your minimum and the maximum. And if you find the difference of the minimum and the maximum, that would be the range of your data, if I'm not mistaken. Let's see. So, whereas the range of so here, no, because the variability in the scores of batsman A is from 0 to 117, whereas the range of the runs scored by the batsman B is from 46 to 60. So that's actually called range. So let us now plot the above scores as dots on a number line. We find the following diagram. So if you plot all of these points on two different diagrams, or on two diagrams and two adjacent diagrams, what you would get is that basically you start from 0 and go all the way up to 120. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 120. And this would be for batsman A, and this would be for batsman B. Again, I do the same kind of diagram here, for example, 0 to 120, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and that would be again 120. So for batsman A, it would look something like this. Something like this. And for batsman B, it would be something like this. 1, 2, 3, 4, 5. So it would be something like this. So you see that, of course, the nature of the data is completely different. So we can see that the dots corresponding to batsman B, this here, are close to each other and are clustering around the measure of central tendency. So the measure of this is 1, 2, 3, 4, 1, 2, 1, 0. This is 10, 20, 30, 40. This is 40, 50, and 60. And the median of the data was somewhere around 53. The average was also 53. So you can see that the points are close to each other and clustering around the measure of central tendency, mean and median, while those corresponding to batsman A are scattered and more spread out. So thus the measure of central tendency are not sufficient to give complete information about a given data. Variability is another factor which is required to be studied under statistics, like measures of central tendency. We want to have a single number to describe variability. The single number is called the measure of dispersion. So there is a term called the measure of dispersion. The measure of dispersion. And in this chapter, we shall learn some of the important measures of the dispersion and their methods of calculation for ungrouped and grouped data. So that's basically all that we want to. I mean, it seems that is all that we want to do in this chapter. And in case you're not familiar with what is grouped data, what is ungrouped data, what is frequency, and all of these things, I will try to explain these as best I can, although let's see how it goes. So I'll see you in the next video.